Hi ladies, okay, so let's go through looking at the 10 different alkane names that you need to know, okay? So starting with the following, okay? So we've got a 1 carbon alkane. You can see that every carbon that we're going to see has 4 things attached to it, and there's no double bonds. That's the kind of key thing with alkanes, all right? So we've got methane. Next one, ethane, 2 carbons. And we said all of these have the same general formula of CnH2n plus 2. Propane, methane, ethane, propane. Butane, methane, ethane, propane. Butane. Pentane. Think of it like a pentagram or something that has 5 things attached to it, okay, or a pentagon. 1, 2, 3, 4, 5, 6 hexane. Hexagon, okay, for 6. Okay, heptane. We're on the right pen, heptane, yeah. 7. 1, 2, 3, 4, 5, 6, 7. Okay, octane. You might recognize that from petrol pumps. Okay, that's the kind of constituent of petrol. Octane. And this is nonane. Okay, which is 9 carbons, and 10 carbons is decane. This is how we draw all of our 10 alkanes, okay? Now the way to sit down and learn this, girls, is to sit down and write them out, okay? And just keep saying over in your head to yourself, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Methane, ethane, propane, butane, pentane, hexane, octane, nonane, decane. And there's a little song on YouTube that you can find that might help you as well. It's literally about sitting down and learning off the number of carbons in each one and the names, okay? You have to know these 10 because it's essential to all the rest of the organic topic, okay? Now let's talk about structural isomers. So structural isomers, we said that these are things with the same molecular formula but different structural formulas, okay? So let's look at the structural isomers for, this is methane, ethane, propane, butane, pentane. This is pentane, okay? So we know that there because there's 5 carbons and there's 12 hydrogens, so it's pentane, right? But there's different forms of pentane, so let's look at these. So we can have the typical, what you'd expect, which is 5 in a row, 1, 2, 3, 4, 5, with 4 things attached each time. So each one's going to have either 3 or 2 hydrogens attached. So you can literally count the dashes coming out. Okay. Pentane. Okay, let's look at another one, okay? Now again, we said there can't be any double bonds, but we could have branches, okay? So we could technically have something in the middle here like this. So 3 carbons, we could have 2 carbons here, okay? We could have a CH3 there, we could have a CH3 there, and we could have 3 hydrogens here. Now let's count up our hydrogens and carbons and make sure that's the same thing. Oh, excuse me. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens, and 1, 2, 3, 4, 5 carbons. So that's definitely the same molecular formula, but you can see it has a totally different structure. It only has 3 carbons in length and 2 CH3 groups in there as well. So there's 2 branches on that. Let's see if we can make another one. So this time we've got 4 carbons in a row with 1 CH3. There, okay. And each carbon still has 4 things attached. Now girls, if you'd prefer to do the CH3s like this, that's okay as well. I'm just doing this for speed. Okay, that's fine as well if you want to do it like that. Okay, so now we've got 4 carbon chain, 1 CH3. Again, let's count up our carbons and hydrogens to make sure that they have the same number. 1, 2, 3, 4, 5 carbons, like we said, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens again. So we've got 3 structural isomers of pentane here. Okay, so hopefully you're getting the idea. The structural isomer has the same molecular formula, same numbers of carbon and hydrogens here, okay, but different structures, okay? So hopefully that's clear there. Now we have to have different ways of naming these materials, okay? Because obviously those three structures are very different, so scientists, when they're working together, have to have ways of naming those. So what we have is what's called a set of rules called a UPAC naming system. Now what that stands for, girls, is International Union of Pure and Applied Chemistry, okay? International is very ringy, I know. International Union of Pure and Applied Chemistry. So the name isn't that important, but the rules are, okay? So first things first, you have to find your longest chain. This forms the root of the name. So is there one carbon? Okay, that means there's obviously going to be methane. If there's 6 carbons, it's going to be a hexane root of the name. If there's 7 carbons, it'll be a heptane. If there's 8 carbons, it'll be octane, okay, and so on. So the number of carbons in the longest chain is important. Now you need to be really careful about this, girls, because the longest chain isn't necessarily the most obvious thing that you can see. Sometimes the chains can be bent because these carbon molecules, girls, can rotate around their bonds. So you have to be careful about that, okay? Then we look at the number of we number the carbons so that anything on the chain, if there's any branches or if there's any other substituents, the substituents are the groups that are attached to the alkane. If there's any other things attached to the alkane, we have to make sure that they are given the smallest number. So we'll have to number the carbons based on the direction so that the substituents have the lowest number. We'll practice that in a second. Then you name the substituents present. So if there's a CH3 branch on the alkane, it's called methyl. If there's a CH2 branch on the chain, there's an ethyl. If there's a chlorine or a bromine or a fluorine, there'll be chloro, bromo, fluoro, okay, and so on, okay? And then we put the full name together. So you write your substituent at the start, the number of carbons that it's on, and then followed by the root name. So let's have a little go of these. Now, so our first one here. So we have let's look at the first one here. So hopefully you can see that there in the screen. So we've got 1, 2, 3, 4, a 4-carbon chain. Okay, so 4 carbons. So methane, ethane, propane, butane. So it will end in a butane. Okay, so hopefully you're clear with that. So 1, 2, 3, 4. Now let's look to see what's attached to our butane. We have 1 CH3. That's our substituent here, okay? Now we have to number our 4 carbons, so that's on the lowest. So if I numbered from this direction, this would be 1, 2, 3. So that's not the way I do it. I have to go 1, 2, 3, 4. So I've numbered my carbons so that my methane is on my lowest number possible. I'm numbering from this direction because otherwise it would be on the 3rd carbon in that direction, okay? So we said it, the root of the name is butane, and we know this CH3 is a methyl group, okay? There's 1 carbon present. We've said that there in the substituents. So now I have to write the full name, okay? And it's going to be 2-methyl butane. Okay, that's how we name that. 2-methyl butane. 2 is the position that the methyl group is on. Butane's the length of the carbon chain. Let's look at this one here. Now this one we've got 3 carbons is the length of our longest chain. 1, 2, 3. So therefore the end of the name will be methane, ethane, propane. That's the root of our name, okay? We have 2 substituents or 2 groups present on this. 2 methyl groups, okay? Now, it doesn't really matter what direction you number these carbons in because the substituents will be on the same one either way. So let's number from this side. So 1, 2, 3, okay? So here we've got 2 methyl groups present on the 2nd carbon. So I'm just going to move this out a little bit so it's a bit easier. So it's going to be 2 di, which means 2 dimethyl propane. 2 dimethyl propane. Okay, that's just telling you that there's 2 methyl groups there and that they're both on the 2nd carbon and that your longest carbon chain is 3. Okay, so I'm hoping this is starting to get a bit clearer. Now let's look at the next one. The next one's quite a long chain. So we've got 1, 2, 3, 4, 5, 6. So this is going to be hexane. Will be our longest chain, okay? Now let's circle the substituents here. There's 2 of them here, 1 and 2. Now, we could number it from this way, but that means that these would have quite high numbers, but we always have to number them so that they're always on the lowest carbons possible. So we go 1, 2, 3, 4, 5, and 6, okay? So that means we have to now write the substituents and their position on the on this molecule, okay? Now the way you do this, girls, is we try and keep it alphabetical, okay? We've got a methyl and an ethyl group. Obviously, the ethyl group comes first, okay? So it's going to be 3 make sure I've gotten this right. 3-ethyl, okay, 3-ethyl, 2-methyl hexane, okay, 3-ethyl, because we've got this 2-carbon substituent here, 2-methyl hexane, all right. Are we okay with that? Now, here's a slightly trickier one. Now, this is one of the kind of trick ones, girls, that they give you. We have to work out what the longest chain is. A lot of people just go straight for this chain, 1, 2, 3, 4, 5, pentane. It's not the case, okay? Our longest chain, girls, is going to be this way, because the carbons can bend. Okay, the carbon bonds can bend. So let's look at this. So 1, 2, 3, 4, 5, 6. Now, if you want to write this out straight, if you find that easier, that's okay. We can do that there now. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You've done that right. 1, 2, 3. On the third carbon in, you've got a CH3 group. Okay, your methyl group. Okay, and the rest is just hydrogens. Remember, every carbon always has 4 things attached at once. Okay. Okay, so let's try and number this or name this now. So we've got a hexane will be our root, and we've got 1 methyl group. We're going to number it from this direction because it will have the lowest carbon number. 1, 2, 3, 4, 5, and 6. Okay, so the methyls on the third. On the third, 1, 2, 3, 4, 5, 6, yeah. On the third carbon, so it's going to be 3-methyl hexane. Okay, are we okay with that? Okay, so what I'll do is I'll set you some workouts about naming the alkanes and see how you get on yourselves. It's a little bit tricky, it takes a little bit of work, but it's worth checking your answers in the workbooks as well. Okay, thanks, girls.